the sausage?
Yeah.
Oh, I was going to heat it up for you.
Too late.
Hey, Cassie.
Oh. Hi.
How are you?
I'm good. This is weird.
I know it is, isn't it?
Yeah. Hang on, let me get upstairs real quick.
Okay.
Hey, Charlie.
That scared me.
Hey, Grace. How are you?
Good.
Good. Just to kind of let you guys know, when I'm writing on the screen and working problems out, I cannot see the chat box that's over on the Google Hangout. So if somebody types, if somebody would let me know, like if they have a question or something like that, I'd really appreciate it. Like, hey, Maggie, if somebody,
Hey, can you hear me?
I can hear you.
Oh, that was Matthew. Sorry.
Oh, that's okay.
He screamed. Okay.
Hey, Matthew.
Kel said hey.
So I was just telling Grace and Cassie that when I start writing, like when I start solving the problems on the other sheet, if somebody types in the chat box, I won't be able to see what they're typing. So if somebody has a question or if I ask a question and somebody types the answer, I kind of need a volunteer to say, oh, hey, Miss Sparks, you know, Grace had the answer or Maggie had the answer, Cassie had the answer. I just need somebody who's willing to be the spokesperson because unfortunately I can't see that chat box and I don't really know how to fix that.
Okay.
So,
right. I'm going to get on my computer. Hold on. I'll be right back on.
Okay.
Okay.
I know that Grace and Cassie, y'all have yours muted currently. So do you all want me to just start with number one and start working them out one by one, or is there a particular one you had a question on?
I think we can just start with number one.
Yeah.
Okay. That works. That works for me.
And then Katie's going to get on here too soon, she said.
Okay. All right.
Yeah, I'm just muted every once in a while because I'm trying to talk to my brother, so.
Oh, okay.
Sorry.
I understand. No big deal. Not a big deal. And people have a tendency, you know, because it's math lab, it's pretty casual, honestly. It's, you know, because, you know, you'll hear my dogs bark and somebody might put something in the microwave, you know, life kind of goes on. So it's just really a place for you. Like if you have a question to come in and, you know, drop in and out as you need it. A lot of times I'll go through an entire worksheet if people want me to. Or if you just have one question on the homework, you can come in, pop in, and pop out. Usually, whatever time, and I need to start doing this, whatever time I post in the lesson, I'm usually there for about an hour to hour and 15 minutes past that.
Oh.
So, you know, so I'm just kind of hanging out until somebody shows up. But I'll start working them. Okay. The way to do this is to look, and I know how much y'all love fractions, but you're looking for a common denominator, just like we were kind of doing when we were adding and actually that we were doing when we were adding and subtracting rational expressions. And this is actually a full-on equation. But you're still going to look for the common denominator. So you're looking for something, you know, that largest common multiple that all three of those denominators would go into. So you're looking for something that x, 3x squared, and 6x squared. What thing would go into all of them? And this first one, you're looking at the 6x squared. Well, I know that I could take an x out of that. So that will cover that one. And I could also take a 3x squared out of that. So really, the greatest common denominator or the least common multiple of 6x squared, 3x squared, and x is going to be 6x squared. Does that make sense to everybody, or is that still a little confusing? Are we good? Should I just start?
Yeah.
Okay. Oops. And I'm going to take a note from something that Mackenzie last year when I was kind of covering this with her a little bit. I used to make a big bracket and just show that I was going to multiply everything by 6x squared. And she thinks it's better, as did one other person that I tutored. I will only throw my own child under the bus. Thinks it's better when I actually break it up and show that I'm multiplying both sides of the equation by the common denominator. So basically what I'm doing is multiplying 6x squared by both sides. And what that's going to happen on this side, this is literally going to cancel out this 6x squared with this 6x squared, because essentially it looks like this. That's really what this side of the equation looks like. Does that make sense to you guys? So that's going to only leave me a 1 on this side of the equal sign. And that's so much more user-friendly. Not scary. Now on this side of the equal sign, how many times will 3x squared go into 6x squared? Like, what's going to be left over? So basically that looks like this. The question that I just asked looks like this. Remember back in the day when we were solving these rational expressions like this, like just reducing them essentially? That's what I'm asking you guys. What would be left with that? Any guesses?
Well, it would be 2, but
Yep.
the x squared cancels each other out.
Yes,
Then
they do. So
okay.
I've only got a 2 left. You're absolutely correct. Good job. All right. Now on this last one, this 1 over x, what we're doing now is what would this look like? This is the final question. What would be left out of that? Did somebody type anything? Like I said, I need a volunteer to read me if somebody types in the chat box. So this is going to cancel out, and we're going to have an x left on top. Did anybody write that? Does that make sense? Oh, we have lots of people here. Welcome, everybody. Okay, now at this point, what I'm going to do is subtract 2 from both sides. And that's going to leave me with a -1 on this side and a -6x on this side. And then I'm going to divide both sides by a -6. And so then that's going to leave me with x equals 1/6. Any questions over that? So that's that one. Moving right along if there's no questions. And if I have anybody that's brave enough to volunteer, if somebody writes in the chat box, I literally cannot see what anybody's writing in the chat box at all when I'm over here working problems. So I kind of need a brave soul to
No
stop.
one is, Miss Sparks. No one's chatting yet. So
Oh, okay, good. Thank you.
you're welcome.
All right, on number 2. Is everybody good with number 1? Is that making more sense to everybody, just seeing a few of them worked out?
Yeah, that was good.
Yeah.
Okay.
This makes
All right. So on number 2, once again, we want to look for the least common denominator of all of these. So what one thing will go into, all of them will go into. Does that make sense to you guys if I say it that way, like the greatest common denominator? Okay. What do you think it will be on this one?
For number 2, did you say?
Yes, ma'am.
X?
It
For all of
even
them?
a little. Yes, all of them. Yes, ma'am.
So it would be X, right?
You're going to go a little bit higher than that because you want to make sure that 2x squared goes into that too. So you're really almost looking for the biggest thing. Remember, like back in fraction days, back in fraction days, if you had a 1/4 and a 1/12 and you're trying to get a common denominator, you went to the biggest one. It's that same principle transferred to this.
Gotcha.
But now we just get to have letters and numbers and exponents. Just to make it all more exciting. Isn't that way more fun?
Mm-hmm.
Okay, so in this case, it's going to be 2x squared. So we've got a 2x squared on that side and a 2x squared on this side. Okay, so we'll take each individual number and multiply it by that 2x squared. And so basically what that means is how many times will x squared go into 2x squared? What will be left over from that? So
2.
if I have, yes, good job.
Yay! I'm getting it.
Yay! So 2 will be left over, and then 2 times 1 is 2. So that's why I wrote that 2 there. Okay, so how many times will x, oops, my bad. X go into the 2x squared? What would be left? If I had
2x.
Yes, good job. That's it. Exactly.
What happens to the x squared?
Okay, so if I have 2x squared like this, and I have an x underneath, that's essentially what we're doing, because if you're looking at it, this is 2x squared over 1 times 1 over x. Does that make sense? Because that's what I'm doing. I'm taking this and distributing it to both places. So just like what we did when we multiplied rational expressions, this would cancel out, right? With this, and it would leave us 1x left there, because remember there's an understood 1 over here, that coefficient, right?
Yeah.
So you've got a 2x left. Does that make sense?
Yeah.
Or no, not quite.
It does.
Okay. So then you've got a 2x left over. So then 2x times 1, which is the numerator there, is going to be 2x. And then obviously 2x squared divided by 2x squared is just 1, and then 1 times 1 is 1. So that's what you have used the greatest common denominator to get rid of essentially the denominator itself, so that you could have just a single lined algebraic expression, which at this point in your math career should be not quite as scary. So then you would just basically simplify this. So I'm going to subtract 2 from both sides. to cancel that out. And so that's going to give me a -1 on this side and bring down my 2x, and divide both sides by 2. And that should give me -1/2. How is that becoming a little clearer?
Yeah.
Okay. Everybody got that? I can erase and move on to number 3.
Yes.
I do know some of those the weekend homework. I'm trying to remember when I was working them out. And I can I will post them on my Google Classroom, and then I'll pass them on to Miss Stone. But one of them, and I really want to say it was either number 21 or 23, actually required the quadratic formula to do the factoring.
I probably skipped it.
I'm sorry?
I said if it was on our homework, I probably skipped it if I didn't know what it was.
Yeah, it was number I think it was 21 and 23. I think those were the ones, either that or 19 and 21. Now I can't remember. I'll have to look. But they were humdingers. They were ones that stretched that old brain, you know, making new neural pathways for my sweet babies. Okay, so we're going to multiply. This is where y'all are going to love this. Love it. We get to factor. And I know that you all were wondering when we were going to get to do more factoring. So what you're going to want to do when you have one of these quadratic expressions, you definitely want to factor that, because it's kind of like when you're getting the greatest common denominator and they were just regular plain old numbers back in the day, when you were actually factoring those to try and find the least common multiple, you kind of want to find out what this is made up of. And the only way to do that is to factor it. So when I factor this expression right here, I'm going to get x plus 7. That's a nice 7, by the way, there. And then x plus 3. Because what you're looking for is what two numbers multiplied together to make 21 that when you add them will give you 10. And that would be 7 and 3. And look, right over here, we have x plus 3 and x plus 7. So that tells me the greatest common denominator is x squared plus 10x plus 21, but we'll show it in its factored form and multiply each side by that.
So could those be canceled out, or no, only if it's on the top and then the bottom?
That's the whole point, is to cancel them out. So that's an excellent question. So, but what we need to do, because we're doing that by both sides, so I hope this will make sense. It's a little difficult sometimes to write on this and write small enough. But what I'm trying to show here, everyone, is that I'm multiplying this side, the left side of the equal sign, and I'm multiplying the right side of the equal sign by this expression in order so that I can cancel out the denominators. That's the whole goal. So I can get that single line algebraic expression that is so much easier to work with. That's the goal of it. So I have this 2x over x plus 3, and I'm actually multiplying it by this x plus 7 and x plus 3. So, so if I do that, if I'm doing that, that actually is going to cancel out that x plus 3, and it's going to leave me with a 2x times this x plus 7. Do you see where I get that? Because basically I'm taking what's left from here and I'm multiplying it by the numerator. And I'm going to do the same exact thing here. I've got an x that's left in the numerator, and then x plus 7 will go into this x plus 7 times x plus 3, and will leave me the x plus 3. That's what would be left over from that. Equals, and then these two will absolutely cancel out and give me an x squared minus 1. So then I would distribute 2x squared. 2x times x is 2x squared. 2x times 7 is 14x. And then I've got a negative x times an x is a negative x squared. And a negative x times 3 is going to give me a negative 3x equals x squared minus 1. Now I'm going to combine like terms on this side. So I've got a 2x squared minus an x squared, which will give me an x squared. And then I've got a 14x minus a 3x, which is going to give me an 11x equals x squared minus 1. And now I want to combine like terms from either of sides. So I'm going to subtract an x squared here. If I did any simple math wrong, y'all will have to step up and holler at me. And Maggie, it looks like you're stuck being the spokesperson.
It's okay.
Okay, so I've got a negative 11x equals negative 1. And so I will divide both sides by negative 11. And that's going to give me x equals 11th.
Sam said, wouldn't the negative 11 be positive?
Oh, yes. Yes. Sam is right. Way to go, Sam. So it's not negative. He was absolutely correct. So my final answer is actually negative. So the answer is x equals negative 1/11. Any questions?
I think I'm good.
Okay. All right. Well, I'm going to erase and keep moving on to the next one. These are some of those things that I just think as you practice, you become more proficient. And just like Mrs. Sparks did just now, you got to be real careful of those simple mistakes because there's, quite a few steps. So you just have to be cautious as you're, working your way through it. All right. As I'm continuing to erase here a little bit, let's take a look at number 4. And can anybody tell me what the common denominator is going to be, where we'll multiply both sides by what? What do you think it'll be here? Giving you a hint. I'm sorry?
Would it be 4x squared?
It absolutely would, Maggie. You're absolutely correct. So kind of, you're almost looking for the very biggest thing usually.
Yeah.
That's just, usually. I mean, there are those circumstances where it's not quite that, but I can't think of one. But I just don't want to say always and then come up with a circumstance where that's not true.
Carson, I have to listen to this.
Okay, so 4x squared goes into 4x squared. What does that leave?
2x squared?
Well, it'll be even. It'll be even out. So those would cancel each other out. So you would only have your numerator left. So the x plus 6, because these two would actually cancel out. Does that make sense? On those, just on this one, since 4x squared goes into 4x squared one time, and 1 times the x plus 6. That's what you've got. And then the 2x squared would give you a 2. And then there would be 2 left. And then 2 times 3 is 6. Does that make sense?
Yeah.
Okay. Because basically on that one, you've got 4x squared. The first one is 4x squared over 4x squared. So that cancels and gives you 1. So you've got the x plus 6 left. And then on the next one, you've got the 4x squared over 2x squared. That's basically what you're looking at. And that would leave you a 2 on the top. And then 2 times 3 gives you 6. And then 2x squared, once again, goes into 4x squared and leaves 2 left over. So you'll have 2 times x plus 4. So now you want to distribute and combine like terms. So on this side, I've got 6 and 6. That's going to be x plus 12. And over on this side, I've got 2x plus 8. And now I want to combine like terms on the different sides where of the equation. So I'm going to subtract 8 from here. And that's going to give me a 4. 2x. And then I'm going to subtract x from over here. And so then I'm going to have 4 equals x. Any questions? All right. On number 5. We got a factor first. So what would the factors be for this one? What do we think the greatest common denominator is going to be on this?
Would it be the 4x squared plus 44x plus 112?
It absolutely would. You're very, very good. But in this particular case, that's absolutely perfect. But the first step that you're going to want to do is you're going to want to factor each one of these.
Mm-hmm.
And so on this particular one, you would take the 4 out, and that's going to leave you an x squared. I feel like we had one of these on the scavenger hunt yesterday. I feel like this is almost the exact one. Does it ring a bell?
Well, I wasn't there, so I don't know.
Oh, that's right.
Walker said yes.
Okay. Okay. I'm sorry it's so spread out, guys. Whoops. Like that, but it's real, like I say, it's kind of hard to write on these. But Maggie, you were absolutely right. This middle one right here, this middle term right there is going to be the least common denominator on that. So what we're going to do is you're looking at this big guy right here, and knowing that you're multiplying both sides of the equal by this. Okay. So what you're going to do, how many times would you be able to take a 4x plus 28 out of this? So basically then you're looking at this right here, and this breaks down to x plus 7, x plus 4. I forgot to do that part for you guys. My apologies. So this 4 is here. This x plus 7 is here. So the only thing I would have left is this x plus 4. So x plus 4 times 1 is x plus 4. Do you see that?
Yeah.
Okay. All right. So now this big whole animal right here, good thing. We don't really have to do much there, because that whole thing cancels out and leaves you with only a 1. And 1 times 1 is 1. So that's for this one here. Now this final one on this end is this part. So what we're looking at, the 2 goes into the 4 with a 2 left over, right? And then 2 times 3 is 6. And then you've got the x plus 7 and the x plus 7, that cancels out. But then you've got this x plus 4. Is there any questions so far? Does everybody see where I got those numbers?
Mm-hmm.
Okay. All right, so now I'm going to technically I have a plus 4 minus 1. That's going to give me a 3 on this side. And then I'm going to distribute this 6 times x plus 4. That's going to give me a 6x plus 24. I'm going to subtract 24. And that's going to leave me x minus 1 equals 6x. And then I've got to have a minus 21 equals, and then I'm subtracting an x from both sides. And that's going to give me a positive 5x. And then I'll divide both sides by 5. I'm running out of space. And then my final answer is going to be x equals negative 5 over 21. Or I'm sorry, my bad. 21 over 5. All right. How was that, everybody? Any questions? Keep moving?
Mm-hmm.
All right. Is anybody typing any questions, Maggie?
No.
Okay. All right. I'm going to try and get this number 6 kind of cleared away so that y'all can tell me, what do you think? What is the factors of the x squared minus 5x minus 66? What are the factors of that one? Anybody factor that? Like what 2 things multiply together to give me
Negative 11 and 6.
Yes, good job. Who said that? Was that you, Maggie?
No, I think it was Campbell, wasn't it?
Campbell, was that you? Plus.
Yeah.
Okay. Good job.
Thank you.
Okay. So now that's its factored form. And so now what you want to do, basically we're going to be multiplying both sides, the left and the right side of the equation, by this factored form of this. So if I multiply this side over here by that, what would you essentially, the x minus 11 would cancel out with the other x minus 11. So that would leave you with x, which is the numerator, times the other factor, which is x plus 6. And then this minus 1, to get a common denominator from it, you would actually, it would be that whole big thing, x squared minus 5x. I'm going to run out of room over here, I think. Bummer. And then over here, maybe I won't because this side's going to be so short. And then when I multiply the right side of the equal sign, I'll have 22. I want to distribute here, which is going to be x squared plus 6x minus x squared. And this minus here, be very, very careful. That has to distribute to each one of these. in the middle. So I've got a minus x squared and I've got a minus 5x. So that makes it a plus 5x. And then a minus 66, which is going to be a plus 66 equals 22. Is everybody following so far? Are we good?
Yeah.
Okay. Okay. The x squared minus x squared, that cancels. You've got a 6x plus 5x. That's going to be 11x plus 66 equals 22. And then you're going to subtract 66 from both sides. And that's going to leave you 11x equals a negative 44 divided by 11 should be x equals negative 4. And then what you want to do on this, essentially what you want to do is just double check your denominator to make sure that you're not ever going to come up with a negative. That's when it says check for extraneous solutions. That's what you're doing, is you're plugging it back into the denominator to make sure you're not getting a 0. So negative 4 minus 11 is a negative 15, so I'm not going to get a 0 there. And then I've got negative 4 squared is 16 minus 20 is negative 4, and negative 4 minus 66 is negative 70. So negative 4 actually works. So that's what they mean, you know, when the directions talk about checking for extraneous solutions. That's essentially what you're doing. Just making sure that denominator doesn't equal a 0, because that's a no-no. All right. Any questions?
No.
Okay. Moving right along. All right. The next one. What do you think the greatest common denominator is going to be for number 7?
X squared minus 5.
X squared minus 5x.
Yep.
Minus 5x.
Yep. Perfect. Y'all are doing great. You don't even need me.
Huh.
You could run Math Lab now. Okay, so x squared, running both sides, multiplying both sides by x squared minus 5x. So the x squared minus 5x here, so that, because it is actually the common denominator, you're just going to rewrite the numerator without the denominator. And then that x, this is what the factored form of this one looks like. Just so that you know, the only thing you'll have to multiply that by, that x, that x would cancel out with this x here. So you've got an x minus 5 left, and you're going to multiply that by the 1. So you've got a plus x minus 5 equals, and then once again, this x squared minus 5x would, obviously, they would cancel each other out and just leave you with your numerator, which is 7x minus 56. Now we want to combine like terms over here on this left side. It's going to give you a 4x, and then 12 minus 5 is 7. And now we'll combine the terms on each side. We're going to subtract a 4x over here, which is going to give me a 3x minus 56. And then we'll add 56 to both sides. So I believe, if I'm not mistaken, that's going to give me a 49 equals 3x. Is that right? Did I do something wrong?
Negative 51.
No. It is? Did I, where did I?
Negative 56 plus 5.
Plus what?
Wait. Oh, you know what? This is supposed to be a plus 7. So 56. Yes. It's supposed to be a 63, actually, right? Yes. Sorry about that. Divided by 3. 21 equals x. There we go. Yeah, back here. That's why I said watch those simple mistakes. They're so easy to make. Bummer. So that was a positive there. So the answer is 21.
I got that. Isn't my 63 negative?
You did?
I have no idea why. Yeah.
Oh, probably because was your 63 on the right side and your 3 on the left? Okay, that's why. You probably moved your 7x to the left, which was fine. And that would have given you a negative 3x on the left. And then you moved your 7 to the right. And that would have given you a negative 63 on the right. And then a negative 63 divided by a negative 3 is a positive 21. So it's just a matter of which side you move things to.
Okay.
And it is more common, I think, for people to try and keep their variables on the left. I moved it to the right, but it is much more common to do it your way. No problem. Still get 21 though, right? Good job though.
Yeah, still did, yeah.
So you're getting the denominator stuff down. That's not an issue for you, that part. Okay, good. Now on number 8, on this particular one, instead of actually factoring, you know how some of them we've had to factor prior to this?
That one you don't.
That one you do not have to factor. It's more like you have to take all of the factors and take those into consideration when creating your common denominator. Does that make sense? So what you're doing is taking your denominator here and your denominator here, and that those two would actually be what you would multiply each side of the equation by. So x minus 1 and x plus 1 is going to be the common denominator that you'll multiply both sides by. So x minus 1, those would cancel, and that would leave you with an x plus 1 times an x plus 1 minus, and then in parentheses, we're going to put a 2x, and then x plus 1 would cancel with this other x plus 1 and leave you an x minus 1 on that side. And once again, I've made myself run out of room. So this is going to be x minus 1, x plus 1 on that side, which that is a special type of square, and it's called the difference of two squares. And that technically, if I FOILed it out, it would be x squared minus 1. So because when you distribute this whole thing out, the middle term actually canceled. That's why it's called the difference of two squares. So if I do this over, if I multiply x plus 1 times x plus 1, gives me x squared plus 2x plus 2 minus, and then minus 2x times 2x is a minus 2x squared, and a minus 2x times a minus 1 is going to give me a plus 2x equals x squared minus 1. Now I'm going to combine my terms. I've got x squared minus 2x squared. That's a negative x squared. And then 2x plus 2x is plus 4x plus 2 equals x squared minus 1. And now I'm going to subtract x squared from this side. And that's going to give me a negative 2x squared plus 4x plus 2 equals negative 1. And then I'm going to add 1 to that side.
Wait. Where'd you get the 2 at the beginning?
Way over here, like here. Is that what you're talking about? Negative 2x squared?
No, the x squared plus 2x plus 2.
Oh, here? Right
Yes,
there?
ma'am.
Okay.
Yes, ma'am.
This x plus 1 times x plus 1, when you FOIL that out, it actually, do you know what I mean by FOIL? Like x times x is x squared. And then 1 times x is 1x, right? And then x times 1 is 1x. So when you add those, it actually turns out to look like this. Oh, this was wrong, though. I'm telling y'all got to watch my simple math right here. That would be 1. Does that look better?
Yes.
Okay. Looks better. Good. All right, so now I need to go back and fix that here. Which means I need to fix down here somewhere too. Everything else look okay? Anything else you catch? Watch me.
I think you're good.
It's going to change this. All right. I think I fixed it all the way down, unless y'all see something else. And so then you would take a negative 2 out, and that's going to give you x squared minus 2x minus 1, which then gives me x minus 1, x minus 1. And that's my final answer. But I have to take that and set each one of those equal to 0. And that's where you're going to check for your extraneous solutions. And so my final answer was 1. And what happens if I plug in a 1 in that very first, yes, and you can't do that.
I got.
Oh, okay. So x doesn't equal 1.
Right. And
it makes a 0.
I got that.
And here's the other thing. This whole thing here, this will tell you how bad I messed this up, because way back here, Miss Sparks did not notice that this was a negative. Way up here. So that would have changed that. What'd you get?
I just got 0 divided by 2x, and that's how I got no solution.
0 divided by 2x, or 2x equals 0?
I got 2x equals 0.
Yeah, 2x
Yeah,
equals 0 is correct, because if I go back and I and I switch all of those negatives around, which I feel really badly that I took y'all down this bunny trail. But if you go back and you fix all of where, because what I didn't notice way, 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 way back up here, like I said, that's a negative, which would change this side over here. Because I would have had this would have changed to this. So you must have kept who is that that's speaking? The guy voice.
Brennan?
Brennan?
Yeah.
Oh, okay. He must have remembered to put his negative in. So I feel bad. I probably need to, what I'll do is rework that so that y'all have all the right one. But the final answer is 0. We're getting that negative 2x. You must have put your negative in. Did you remember the negative, Brennan? Is that way back where Miss Sparks didn't? You did? Good job.
Yeah.
Way to go. Way to go. So it actually would have looked like, let's see. Just so that everybody who followed my bunny trail before will have the right one. I want to make sure that you have the steps correct. Oh. When I add x squared here. Whoops. And then the -1. And I'm running out of room again. Fun stuff. There you go. Y'all can stop me when you see that I do something wrong. So the simple errors are what kill everyone, including the math teachers. Okay, so the answer to number 8 is actually correct. It is 0. X is 0. All right. Number 9, the least common denominator for number 9. You would want to factor that x squared plus 8x plus 7 first. Anybody have guesses as to what that will factor to?
X plus 7, X plus 1.
Good job. That is it. That is absolutely correct. So for both sides of the fraction on this one, you're going to multiply that by the x plus 7, x plus 1. So on the other side, the x plus 1s would cancel each other out, leaving you an x plus 7 times 1. And then for the first fraction in the second part, it's going to leave you the x plus 7 again, but this time you're going to multiply it by the 2 and have x plus 7. And then for the last one, the whole thing would cancel each other out, and you would be left with 1. And 1 times 1 is 1. So you're going to want to distribute on this right side. So 2x plus 14 plus 1. And then you're going to bring your 2x over by subtracting 2x from both sides. And then negative x plus 7 equals 15, because your 14 plus 1 is 15. Subtract 7 from both sides. You get negative x equals 8. And then divide both sides by negative 1. And x equals negative 8. And that's the answer for number 9. Does everybody want me to keep working? Or is everybody good on their own?
Can you do 11?
Yes.
11.
11. I heard 11.
Yeah.
Yes, ma'am.
Okay. Yes, I can. Okay. First thing that you would want to do is factor. And can't really factor anything out, or try to factor. And you can't really factor anything out. So actually, to be perfectly honest with you, what I would do on this is go totally old school and cross multiply. Does that make sense to everyone? I would go 8
But
times.
why would you do that?
Why would I do that? Why would I? Is that what you're asking? For me, I mean, I could multiply both sides by a common denominator in all honesty, but that's going to be that's actually going to be 3x minus 2 times x minus 1.
Okay.
So I'm going to create a really big animal when I really only have to cross multiply. What did you do?
I factor out the 3 plus 2, or like 3 minus 2.
And what'd you do?
How?
I don't know. I just saw that you could multiply 3 plus 2 times x minus 1. That's just sort of how I did it, but it didn't work. So
Okay. I mean, that's just what I think I would do on this one. You know, and every now and then what I do notice about these wonderful little math sheets is that they do something where they will throw something in kind of where you can kind of go old school. And that is your answer. Just to kind of, you know, keep you on your toes, I guess. But that, yeah, when it's real simple like that, you don't have to do anything else. You don't have to complicate. I guess technically, to be perfectly honest with you, if we're multiplying both sides by the common denominator, it's going to be each of the factors anyway. So it's really the same as cross multiplying if you think about it, because if this 3x minus 2 is going to cancel out with this and leave you with x minus 1, which you're going to multiply by the 8 anyway. And this, does that make sense? That's really probably where cross multiplication came into the first place.
So what's the answer?
2.
Okay.
Wouldn't it be negative?
Oh, yeah. No, I got positive. Why did I get positive? Yes?
It's
Well, because then you would
positive.
bring the -4 over and you would actually add it to the -8, which would make it a -4
Well,
divided by 2. Or
I see this because when I distributed the 2 to the 3x minus 2, I got 6x minus 4. Did you follow that step? And then I subtracted 6x from both sides. That left me 2x minus 8. And then I added 8 to both sides.
It's positive because the 8 is positive. So when you subtract the 8 with the -4, the overall answer is positive.
Yes. Because I've got a -4 combined with a positive 8.
When you distribute like the 8 to the x minus 1 at first, wouldn't it be a -8?
Yes, it would. And in order to get rid of it on this side, see this step right here? In order to get rid of a -8, you have to add 8. And whatever you do to one side of the equation, you have to do to the other. So this adding 8 to the -8 cancels it here and makes that 0 and leaves you with your 2x. But I have to add it over here also. And I'm adding an 8 to a -4.
Okay, I was bringing the -4 over to the -8 instead of doing it the other way.
Oh, okay. Well, that would give you like a -12, but then you would have had to move your 8 over. No, actually, it wouldn't have. It would have given you a -4. I'm sorry. Yeah, because you would have added 4 to both sides. So it would, yeah. So once again, you kind of did what I did earlier and put your variable on the right and your x on the left. I mean your constant on the left, which should have given you 2 negatives at the end.
That.
Well, even if you have 2 negatives, it would still come up with a positive. Does that make sense? You still should get the same answer no matter what side you put your variable on.
Okay.
So it should work out. It's just going to be one of those things where you're going to end up with 2 negatives or 2 positives. And 2 negatives do make a positive. So did somebody have a question? 16?
Can you do 13 next? Oh.
Okay. Yes. So I want to do 13 and 16. That's what I'm hearing. Is that correct?
Yeah.
Okay. Does anyone care if I just go in order and do 13 and then 16? Any objections? Okay. For number 13, the common denominator is going to be x minus 3, x minus 5.
Yep.
Does everybody see that? No questions there.
So don't you only have to multiply by what's needed?
Yeah.
Kind of. Yeah, that's a good way to look at it. Because like what you're doing is you're dividing out that x minus 3. So then you're left with x plus 3 because you still have to keep that numerator, right? And then x minus 5 plus, and then you've got an x as your numerator, and what would be left here would be your x minus 3, correct?
Yes.
Okay, so, and then over here, you're going to multiply x plus 5, x minus 3. Because the x plus 5 is what the numerator was, and I have to multiply with whatever is remaining. Okay. So x plus 3 times x. What? Did I do something wrong, Brennan?
Why would you have to multiply the x minus 5 over?
Which?
Oh, never mind. I see. I think.
Okay.
Yeah, I see.
All right. Okay. I'm just checking because
just
I know earlier y'all caught me on that other thing. I was like, "Whoo, I don't want to go any further."
I
And
was
mess
just
anybody else up.
I didn't write that step down.
Ah, I got you. You just kind of did it in your head.
Mm-hmm.
That's because you're way smarter than me, Brennan. X plus 3, x minus 5. So if I FOIL that out, I just want to make sure everybody understands what I mean by FOIL that out. Like I'm actually distributing the x to the x minus 5 and the 3 to the x minus 5. And so when I do that, I'm going to get x squared minus 2x minus 15. Does everybody understand where I get that?
Mm-hmm.
Yep.
Okay. And now I'm going to distribute this x to the x minus 3, and I'm going to get x squared minus 3x. And then over here, I'm going to get x squared plus 2x minus 15. And now I want to combine like terms. So I've got a 2x squared minus 5x minus 15 equals x squared plus 2x minus 15. So I'm going to subtract an x squared from here. And that's going to give an x squared from here. That's going to give me x squared. And then minus 2x minus 5x is a minus 7x. And a plus 15 to a minus 15 is 0. Correct?
Yeah.
Okay. And then I'm going to factor an x out. I've got x minus 7. So I should have x equals 0 and x minus 7. So x equals 0 and then x minus 7 equals 0. So x equals 0 or x equals 7. And I want to double check those and make sure that when I plug a 0 or a 7 back into number 13 for the denominator, that neither one of them would equal 0, which would give me an extraneous solution. And neither one does. So both of those answers are valid. Did that make sense? Okay, and then number 16. Okay, I'm trying to get clear 16. Okay, what do you think? Okay, this one can definitely be factored. So we want to try to figure out what the common denominator is by factoring and seeing if we have anything in common with each other. And it looks like we've got on this one, we can factor a 4 out, and that's going to leave us with x plus 3, which is the same here. And here we've got a 3. We can factor a 3 out with x plus 3. So it looks like our common denominator is actually going to be 12 times x plus 3. Does that make sense?
Yeah.
Okay. So, and if you want to keep them, if it makes more sense to you guys, to keep this, instead of writing the 12 like, out, if you just kind of want to remind yourself that it's broken into these two factors, so that when you look at these, you can be like, oh, okay, that's exactly what's left over. Does that make sense? I don't know if that helps you all or makes it worse.
I mean, the 12 is easier because it's easier to write, but
Okay. So that technically would be this. So what would you, I'm sorry?
you're good. You're good.
Okay. Okay. So what would, if you have 4x plus 12, what would you have left that you would have to multiply the numerator by on this first fraction here?
3.
Absolutely. So you would have 3 times 2, which would be 6. So I've got 6 equals, and then 3x plus 9 would go into that. What would you have left that you would have to multiply that 9 by? 4. And then 4 times 9 is 36. Minus, and then we've got 2x minus 2 times what would be left out of that one. Once again, I think, Brendan, you said earlier 3. So instead of writing it that way, because it's just easier to distribute. All right, 3 times 2x minus 2. So now I distribute 33 times a negative 3 times 2x is a negative 6x, and a negative 3 times a negative 2 is a positive 6. So that's going to give me 6 equals 42 minus 6x. And then I've got, I'm going to subtract, here's that whole discrepancy of keeping the constant on what side. I'm going to subtract 42 from both sides. It's going to give us a negative 36 equals a negative 6x, which if you had it vice versa, it would just be positives. And then your answer is going to be 6 equals x, or x equals 6. Any questions on that one? And are there any more that you would like for me to do?
Um, 17.
Okay. So the common denominator on that one is just going to be 2x plus 10. Correct?
Uh-huh.
So multiplying both sides of the equation by 2x plus 10. On that first one, you're just going to bring that down. So that's going to be x minus 3 plus, and then
4x. Sorry.
2x minus 12. And I'm going to tell you something that I would do with this for me personally when we get back to that one step. On this step here, for me, I would probably factor the 2 out before I FOIL on each of those. So I actually would even do like 2 times x minus 6. And then all of this would then be 2 times x plus 5 equals x squared plus 3x minus 18. And then this actually is going to be a 4 here times, and then you've got x minus 6 and then x plus 5, which is going to be x squared minus x minus 30. And then I would redistribute that 4 just because it's so much easier to FOIL numbers like that and then combine. Does that make sense?
Okay.
Just because working with small, there's your answer key. Yay. So y'all can check your answers, but we've already really done them. But anyway, so that's just what I would do. Just because, you know, I like working with the smaller numbers where I can. Sorry, the writing gets so bad on here. All right, so now we get to combine all this stuff. We've got a 4x squared leading the way. And then we've got an x minus 4x, which is going to be minus 3x. And then we've got a minus 3 minus 120 is a minus 123. Did y'all get that anywhere in your steps?
So, wait.
No?
Go back a step.
Okay.
So, x minus 3 plus minus 4x minus 120 equals x squared plus 3x minus 18.
Yes.
Then what did you do?
And then I combined my x with this x here, this x and this. Well, I brought down my 4x squared, first of all, and led the way because there were no other x squared terms on this side. And then I combined my x minus 4x, which gave me a minus 3x. And then I combined my minus 3 with my minus 120.
Got it.
And then I've got x squared plus 3x.
Yep.
Plus, minus 18 over here. I can't even read my own writing. All right, so I'm going to subtract an x squared and get a 3x squared here. Do you see that? And then I've got a plus 3x here. So when I subtract 3x from the right side and move it to here, I'm going to have a minus 6x. Do you agree?
Yeah.
Okay. And then I've got a
6x.
I'm sorry?
X squared minus 6x minus 123 now.
Well, no, because I moved this x squared over. I subtracted this x squared over here. So I should have a 3x squared minus 6x squared. Do you see where I get that? And now I've got a minus 18.
Yeah.
Okay. And so I'm going to add 18 to both sides. Right?
Uh-huh.
And so that's going to give me a 105. Right? A negative 105. And so I'm going to factor a 3 out.
Would you not multiply the first?
Well, you could multiply the first and the last and do the A and the C thing.
Yeah.
I mean, you definitely could do that. I was just going to see if I took the 3 out, because I know 105 is also divisible by 3, because when the digits 1, 0, and 5 are added up, they add up to be 6, which is a multiple of 3, and that shows me the divisibility test. Right? Because 1 and 5 is 6. So that this is 35. And that is easy. I mean, you could do it the other way, but this is easier to factor. So you've got x minus 7, x plus 5 equals 0. So then you've got x minus 7. So x equals 7 and x equals negative 5. And then you would want to look at those and see if anything, if either of those would make the denominator a 0, which I believe the negative 5 does. Because if I plug back in a negative 5 in there, I've got 2 times a negative 5, which makes that a negative 10. So negative 5 is an extraneous solution. So x equals negative 7 is the only correct answer that works. Any other questions?
19.
Okay. Okay, looking at 19, we know that we can factor some things out, so that'll help. So what would the greatest common denominator be?
X squared plus x.
Yes, sir. That's it. And what we know what that looks like, just to write it in its factored form so that you can kind of see what's left. Oh, look at all that I still have to erase. Sweet Jesus. Okay. We got x plus 1. And that's what we're going to multiply both sides by, both sides of the equation. And so if we do that here, we don't have anything left. I'm going to write that at the top. Except for the denominator itself. I mean the numerator, which is x plus 5 equals, and then once again, same for this first fraction or rational expression on the right side of the equal sign. So it's going to leave us 1. And then here, you'll have an x left. So you've got x times the numerator, which is x minus 6. So x plus 5 equals 1, and then distribute this x. A negative x times x is x squared, and then a negative x times a negative 6 is a positive 6x. So now we want to try to bring everything over onto one side of the equation. So I'm going to add an x squared to both sides. It's going to give me x squared, and then I'm going to subtract this 6x, and combine it with this x over here. I don't know if that's too many steps for somebody, and if it is, I apologize. And then, so I have a negative 5x. And then I'm going to take this 1 and then subtract it from here, and I'm going to have plus 4 equals 0, because this canceled, and I actually subtracted a 6x here. So that canceled and subtracted a 1. So then I've only got this x squared minus 5x plus 4. Was that too many steps in one? And then my final step is going to be x minus 4, x minus 1 equals 0. So x equals 4 or x equals 1. And plugged back in, 4 squared 16 plus 4 is 20. That's not going to be a problem. And 1 squared plus 1 is 2. And then 4 plus 1 over here on this particular one is 5. And 1 plus 1 is 2. So neither one should be an extraneous solution. So the answers are both 1 and 4 or 4 and 1. Did I do this in too many steps? Was that too confusing? I kind of feel bad. Was everybody okay on that? Any other questions? Do y'all want me to keep working any? Think
Emma said 14.
14? Okay. Thank you. Okay. $14. All right. Oh, how cute. It's all real numbers. That's sort of friendly. Okay, on this one, the common denominator is going to be 6. So you would multiply both sides of the equation by 6. And 2 goes into 6 3 times. And 3 times 1 is 3. And 6 obviously goes into 6 one time. And then 1 times the 2x minus 3. And then 3 goes into 6 2 times. And then 2, there's the 2 times the 2x. So then you're left with 3 equals 2x minus 3 plus 4x. And then I'm going to combine my 2x and my 4x, gives me 6x minus 3. And then I add 3 to both sides. Gives me 6 equals 6x. Divide both sides by 6. And I should have 1. X equals 1. Any others?
Walker said 20.
20. Okay. Thank you.
Yep.
Okay, so the common denominator on this one is actually going to be your x cubed plus 5x squared. But just so that you can kind of see what's left over for each of these, I'm going to write it in its factored form that kind of matches. So we would take that x squared out of it, and it would leave you with x plus 5 on both sides. So you would multiply. So this, obviously, the x cubed plus 5x is this right here. So on this side, you only have a 5. So that would go into that one time, and 1 times 5 is 5. And then over here, x plus 5 goes into that with an x cubed left over. And then you've got 4x cubed because you're multiplying your numerator times what is left. And then the x cubed goes into it, and then you've got an x plus 5. So because x plus 5 times 1. And so then what we have left here is let's subtract 5, and that's going to give you 0 equals 4x squared plus x. And then essentially what you have is 0 equals, and then 4x times x plus 1. So 4x equals 0. So x equals 0, and x equals -1. Or did I do something wrong? Brennan?
Can you scroll down some, Miss Parks?
Yeah. Perhaps.
I thought you can't because it's just an X and not a 4, so you can't break out a 4.
Okay.
I could be wrong, but
True. True that. I think you're right. You're right. Oops. X. There. That's better. You're right. X equals 0. And then 4x plus 1 equals 0. And then x equals -1/4. Yes. Okay. Better. Much better. That feels better. All right. So when we plug in a 0 back into the denominator, though, that would be an extraneous solution because 0 squared is 0. So that the 0 will not work. So it's an extraneous solution, but the -1/4 will work. So that is the only answer that works. Any others? I feel like we almost hit all of them.
We literally only have 3 left.
Do you all want me to do them? It's up to y'all.
Walker said yeah.
Okay. Which ones are they? I don't even remember now.
10, 15, and 18.
10, 15, and 18?
Yes, ma'am.
All right. Well, I'm just going to go backwards. I'm gonna go with 18, and then y'all can remind me which ones they were again. Okay. So on this one, the factors are x minus 3 x plus 1. And this is the least common denominator, but I will actually multiply both sides by that. I'm going to get it out of here so I have more room to work. Put it at the top. X minus 3, x plus 1. Okay, so x plus 1 goes into that, leaves the x minus 3. So that's going to be 5 times x minus 3. And then obviously on this side of the equal sign, that whole common denominator is only going to leave you with the 6. It stays pretty much the same. And then x minus 3, it's going to leave you with the x plus 1. So you've got 1 times x plus 1. I'm going to distribute on this side. 6 plus 1 is 7. So on this side, I've got x plus 7. And then I'm going to subtract x from this side. And that's going to give me 4x minus 15 equals 7. I'm going to add 15. And that's going to give me 4x equals 22. Did I do something wrong? Not that I should be afraid of fractions at this point. I just always question when you get whole numbers for so long and then all of a sudden, bam, you get a fraction. But x equals 11 over 2. The good news is usually with fractions, there's not very many extraneous solutions. I guess that's the good news with those because they don't very often come out to be 0. Okay, so that was number 18, correct? And then what was the other one that I skipped? Was it 15?
15 and 10.
15 and 10. Okay, so in factored form, this x squared minus 8x plus 12 is going to be x minus 6, x minus 2. So that's what we've got on this side too. So you're actually multiplying both sides by that. It's going to leave you a 4 on this side. And then over here, you're going to have x times x minus 6 plus, and then 1 times the x minus 2. So I'm going to distribute. And then combine my like terms. And so then I'll factor that, and that's going to give me x minus 3 Oops. X minus 6, x plus 1. Here we go. So I've got x equals 6 or x equals negative 1. And when you plug those back in, will one of them not work? Yes, the 6 will not work because here you've got 6 minus 6, which would give you a 0. So it will not work. So the only solution is the x equals -1. The x equals 6 is an extraneous solution. And I believe the last one is number 10. I appreciate everybody coming to Math Lab, and I certainly hope that this has helped clarify any questions that you might have had, or help you watch the steps because you saw Miss Sparks make some. Those simple mistakes can really get you every time. And you got to watch them because, as I did on that one, I made it early on. So just watch. Please show your work. I know that's important to Miss Stone. It's important to me, but show your work and watch your steps. And number 10, I think that'll be it for the worksheet, right? Okay.
Yes, ma'am.
So we'll factor this, and the factors are x plus, nope. I wanted it to be that. X minus 5, x minus 2. And we'll multiply both sides of the equation by that. So when you divide that by x minus 2, it leaves you with the x minus 5 times 1 is itself, plus, and then x squared minus 7x plus 10 is actually what that is. So plus 1, and then x minus 2 goes into x minus 5 times x minus 2 with the x minus 5 left. So you've got x minus 4 on this side, x minus 5 on that side. Uh-oh. And so then when I subtract an x from both sides, that leaves me a 0. And that says -4 equals -5. And that is no solution. Because -4 does not equal -5.
Thank you, Miss Sparks.
Hey, no problem. Thanks for hanging with me. How many people did I end up having stay with me the whole time? Oh, quite a few. Good job. Thank you all for staying. I hope that helps. Andrew, it looked like you had a question. Do you guys want me to show you the answer key so you can double check for those of you who hopped in a little later? Okay. Sure. I will do that.
I think actually the last 2 pages of the worksheet that
Yes.
were posted are the answer key.
What?
So.
Yes, they are. Here you go. I'm going to leave that there for a few minutes and y'all can check through them. Let me know when you're ready for me to move it. And remember, I can't see the chat box, so somebody can say you're ready. That would be great. Okay. Ready?
Yep.
Is Brennan still with us?
No, ma'am.
Okay. Because I think he had asked for the answer key earlier. So,
I think I've got everything. Thank you so much, Miss Sparks.
hey, no problem. Thank you for coming to Math Lab.
All right, bye. See you tomorrow.
All righty. Bye-bye.
See you tomorrow, Miss Parks. Thank you.
You're most welcome. You're most welcome.
Works.
You're most welcome. Y'all have a blessed afternoon. Take care. You're welcome, Caitlin.